3.3 is derivatives of products and quotients. So we've got two rules in this section that we're going to learn about, the product rule and the quotient rule. We'll start off with the product rule. If y equals f of x, which equals capital F of x times capital F of s of x, notice what they're telling you here is you're going to have two separate functions in the problem that are being multiplied times each other. So they're showing you how you can take the derivative when you see this is happening. They labeled them this way because they're calling this one the first function and this one the second function. That way it's easy to see what they're doing in the formula. And if both of the derivatives exist, then the derivative is going to be you leave the first function alone, you take the derivative of the second function, plus you leave the second function alone and you take the derivative of the first function. Really, because there's a plus sign in here, it doesn't matter which one you take the derivative of first and which one you take the derivative of second, as long as you're just taking one derivative in this one and then the other derivative in this one. Okay, but we'll follow the formula so that we can just get used to it. In example 1, we've got find f prime of x, and we're given f of x equals 2x cubed times x squared minus 2. Okay, well this is our first function and this is our second function, so let's go ahead and follow our formula up here. So we've got f prime of x equals, well we're supposed to leave the first function, so 2x cubed times, take the derivative of the second function. Well, we just need to use the power rule. We can put the 2 down in front, so 2x, and subtract 1 from the power is just going to be 1. The derivative of a constant is 0, so that's it right there. Plus, leave the second function, so x squared minus 2, and take the derivative of the first function. So again, power rule, bring the 3 down, so 3 times 2 is 6, x, and then subtract 1 from the power gives me 2. Okay, and we found the derivative right here, but let's go ahead and simplify it. So we've got 4x to the 4th plus, and I'll distribute my 6x squared here, so I've got 6x to the 4th minus 12x squared. And finally, I can put my like terms together, so that gives me 10x to the 4th minus 12x squared. I don't require you to simplify, but if we have multiple choice tests, the answer might just be displayed like this. So it is important that you know how to simplify and get down to this answer if you need it. Well, and I also wanted to simplify it completely because I wanted to compare it. Look at what they gave us to begin with. We didn't have to use the product rule. We could have set our problem up so that we could just use the power rule. So let me just show you another way this problem could have been done. Okay, so I'm going to rewrite my problem. Okay, so my f of x, if I multiply it out, distribute the 2x cubed here, we get 2x to the 5th minus 4x cubed. And then we could just use the power rule. So f prime of x equals, bring the 5 down, so 5 times 2 is 10, x subtract 1, so to the 4th power, minus, bring the 3 down, 3 times 4 is 12, x subtract 1 from the power, squared. Well, that's what we got up here. Okay, of course, this way was easier. So if you see a problem like this, I'm not going to mind if you do it the easier way. Okay, we just started with a problem like this because, as you'll see in B, there isn't an easier way. We do have to use our rule that we just learned. Okay? So of course, in a problem where you have a choice, you can choose whichever method you like better. But we do need to know the method because, like problems like B, we have to use the product rule in order to find the derivative. Okay, in this one we've got my first function is x to the third power, and the second function is the natural log of x. So we can go ahead and find the derivative. F prime of x equals, again, we're going to just follow our formula. So the first one leave alone, so x cubed. Take the derivative of our second function. Well, the derivative of ln x, remember, is 1 over x. We learned that in our last section. Plus, leave the second function alone, so ln of x times take the derivative of the first function. So bring the 3 down and subtract 1 from the power. Okay, well, we can do a little bit of simplifying in this problem. X cubed divided by x is x squared, plus we'll go ahead and move that 3x squared in front of the natural log so we don't have to write parentheses. And sometimes people see that there's an x squared in both of the terms, so they go ahead and factor out the x squared. Okay, but that's just a preference. And again, if you've got a multiple choice question, that's why I'm going through and simplifying this, in case you might see the answer written like this, or you might see the answer written like this. You know they're the same answer. Let's try one more. F of x equals 3x times e to the x. Okay, well, our first function is 3x, our second function is e to the x. So we'll go ahead and find the derivative. Leave the first function alone, so 3x times the derivative of the second function, e to the x. Well, the derivative of e to the x is e to the x. Plus, leave the second function alone, e to the x, times the derivative of the first function, which is just 3. And again, this one's pretty much simplified, but I do see there's a 3e to the x in both of the terms, so I'm going to go ahead and factor it out. So there's a 3e to the x in common in both of the terms. There's just an x left here, and we took out the 3e to the x, but remember there's a 1 to hold the spot because you have to be able to multiply this back out and get what you started with. Okay, so those are some examples of the product rule. Let's take a look at the quotient rule. Okay, so the quotient rule, if you have f of x equals t of x over b of x, again, they wrote them this way on purpose. T is for top, b is for bottom, so you can easily read the formula. And if both of the derivatives exist, then f prime of x equals, you'll leave the bottom alone, take the derivative of the top, minus, okay, this one has a minus sign, so it does matter what order you do it in. So make sure you're leaving the bottom alone and taking the derivative of the top first. Minus, leave the top alone, take the derivative of the bottom, and then all over the bottom squared. So let's go ahead and try this formula out. In part A, we've got f of x equals x squared plus 1 over 2x minus 3. Well, let's find the derivative. We're supposed to leave the bottom, so we've got 2x minus 3. Take the derivative of the top. Well, that's going to give me 2x. minus, leave the top, take the derivative of the bottom, which is just 2, over the bottom squared. Okay, and then just simplify. Normally you don't need to multiply out the bottom because you want to leave it in factored form in case there's some factors that end up canceling out. So you don't need to multiply out the bottom. Just go ahead and multiply out the top so that it can be simplified. So we've got 4x squared minus 6x, and then we've got a negative 2 here. I'm going to bring that negative to the 2 so that I know I'm distributing negative 2 through this to make it easier. So negative 2x squared minus 2, and I'm leaving the bottom alone. And then let's see, we've got 2x squared minus 6x minus 2. I've already played around with this one a little bit, and I know that I'm not going to be able to factor this one to make it cancel with any of the factors on the bottom. So I'm just going to leave my answer like this. But if you're looking at a multiple choice test and you see that you don't find your answer as one of the answers in the selection, you might have just needed to simplify further. So don't necessarily think your answer is wrong to begin with. See if you can simplify it a little bit more, and then also, of course, check through your work. Let's try another one. So I've got f of x equals e to the x over x squared plus 1. Okay, well, let's go ahead and take the derivative. So we're supposed to leave the bottom alone. So we've got x squared plus 1 times, take the derivative of the top. Well, the derivative of the top is the same. Minus, leave the top alone. Take the derivative of the bottom, which is 2x. All over the bottom squared. Okay, let's see. The only thing I see that maybe we could simplify is on the top, both of the terms have an e to the x power, so I could factor that out. So I've got e to the x, and then I'll have an x squared plus 1 minus 2x left. Let me put that in the correct order. We've got x squared minus 2x plus 1 left. Okay, it doesn't matter what order you put the terms in, but if you want to try to factor it, it's nice to have them in descending order. That way I can see there's just a 1 in front, so that means my middle term is my sum, my last term is the product. What two numbers multiply and give me 1, but when I add them I get negative 2. Well, negative 1 and negative 1. So if I wanted to factor this one, I have e to the x times, they were both negative 1 and negative 1, so x minus 1 squared all over x squared plus 1 squared. But even though I factored it, I see that the factors are not the same on top and bottom, so I can't cancel anything anyway. So depending on what book you're looking at, they might leave the answer like this, or they might change the answer to this. All right, and example 3, I actually don't use the product rule or the quotient rule in example 3, but I wanted to give you another example of finding the equation of the tangent line since we didn't do one in the last section. So that's why I wrote this one down. Okay, so it says find the equation of the line tangent to the graph of f at the indicated value of x. And they give me f of x equals 3 plus ln x, and x equals 1. Well, I wrote down our formula. Remember the equation of the line, y minus y1 equals m times x minus x1. And we've done an example like this before. Let's remind ourselves how to get all of the pieces. The x1 is the x they give you in the problem. The y1, well, you just take your x1, plug it into your original function to find your y1. So let's write that down. y1 equals, use your original function and plug whatever your x1 was into it. So we've got 3 plus ln of 1. Okay, and it doesn't matter what the base is for the log. If you're taking the log of 1, that's 0. So this is just 3. Remember what your m is. Your m is you take the derivative of your function and you plug that x1 back in. Okay, well, we need to know what the derivative of this is then. Let's put that right here. The derivative of a constant is 0. The derivative of ln x is 1 over x. Okay, well, we've got our derivative. Let's plug 1 in for x. So we get 1 over 1, which equals 1. And then we've got all of the pieces we need. So let's plug them in. We've got y minus my y1 was 3 equals my m was 1 times x minus my x1 was also 1. Okay, and then we usually like to write it in slope-intercept form. So I'm going to distribute the 1, which really doesn't change anything. And then get y by itself, so add 3. Okay, so just another example of finding the equation of the tangent line for you. Try out the homework and let me know if you have any questions.